Welcome to Computer History with Chris Garcia. I am, in fact, Chris Garcia. Today, the path out of Lincoln Labs, the TX machines, LINC, and the PDP-1. The age of the vacuum tube machine was clearly coming to an end as early as 1955. There were experiments, even slightly earlier than that, at using transistors for computing, most notably in the UK. MIT had Whirlwind active as one of the most important computers of the day, having been the machine that introduced core memory to the world. There was also a lot of track laid for the idea of microcoding, though it was Maurice Wilkes in the UK who really fleshed out that idea. There were a couple of things that Lincoln Labs wanted to address. They had Whirlwinds running with core, but transistors clearly the next step forward. They wanted to build a transistor version of Whirlwind. They also wanted to build a machine to serve as a memory test system. The system they built? TX-0, or the Transistor Experiment 0. Wesley Clark was chosen to do the logic design, and he made good work of the assignment. Since it was a memory test machine, it had some weirdnesses, like an 18-bit word length with 16 bits address space and 2 bits for operation code. This meant that it was really an early form of RISC machine. MIT professor Jack Dennis described it like this. 1. You must be able to store information into memory location. 2. You must be able to get information out of memory so one can operate on it in the central processing unit. The TX-0 does not have an instruction code load. In TX-0, one got information into the accumulator by clearing the accumulator and then executing an add instruction. 3. The third instruction of TX-0 was transfer negative, transfer control to the location specified by the address. 4. The operate instruction was next. Anything not done by the other 3 kinds of instructions was done by the operate instructions. The remaining 16 bits, instead of referring to the memory location, were simply a microcoded extension of the operation code. One combination would cause a point to be displayed on a cathode ray tube, CRT, whose coordinates were the right half of the accumulator and the left half of the accumulator. In the same instruction, you could transfer the contents of the accumulator so that it could cause on the next repetition of instructions, a different point to be plotted on the CRT. At that point, there were a few stumbling blocks. First, there was difficulty of access to reliable transistors. There are more and more transistors entering the market, and they tended to provide less optimal performance for use in computers. And reliability was a significant issue. The availability of surface barrier transistors from Philco, costing $40 a pop, made that possible, and they made an interesting choice with them. They put them in little bottles. Supposedly, the reason for that was a practical one. Primary engineers, Ken Olsen and Ben Gurley, weren't sure if the transistors were going to have staying power. They had already once had to transition out of vacuum tubes to transistors. So they wanted to make it easy to upgrade to another processing element. Also, having transistors in a pinned unit, 10 to a bottle, made it possible to test them at least annually. Though this turned out to be unnecessary because if they were going to fail within 10,000 hours, they tended to fail in the first 500. Hours. The machine had some impressive innovations. Whirlwind had used a CRT display, but it was more for things like data representation. In TX-0, it was more used as a display for the operator to interact with. This was an important element, and it would become even more important in the follow-on, TX-2. Now you may ask, as many have, where was TX-1? It had been considered before even TX-0, but it would have been a tube machine apparently. The design was scrapped and they did TX-0 and then skipped it when Clark designed TX-2. He even once quipped, "We don't make odd computers." TX-2 was, by far, the more robust machine, and one that really influenced a lot of future work. The machine had 64K words of core memory, and they did away with the bottles and moved to plug-in modules. This, though, wasn't as important as the concept of interactivity that it represented. There was a CRT, and one innovation allowed for interaction in a new way, the light pen. While we had the light gun on Sage, the light pen was a more flexible technology, and it enabled one of the most important innovations of the 1960s as far as software goes, Sketchpad. Designed by Ivan Sutherland, it was a graphical interaction system that utilized the light pen and enabled early forms of computer-aided design. While DAC was a contemporary to Sketchpad, it was more of a machine-specific system, while Sketchpad could theoretically have been ported to other computers, Early forms of multi-user time-sharing like Apex were developed on TX2. Early work on networking was investigated on TX2 with Leonard Kleinrock and Larry Roberts, two of the major driving forces behind ARPANETs, working on TX2. In fact, Kleinrock developed his theory of packet networks on the TX2. There was an innovation that really could be seen as the through line to all machines in this episode: the block addressable tape system that started on the TX2. The TX2 tape system was a major advance over sequential tape systems, as it allows you to address and write and read from specific blocks within the tape instead of having to go through the entire thing to get the piece of information that you want. Now, Wesley Clark had been the primary designer of both TX systems, and he stuck around Lincoln Labs, but had another project that was in a similar line with the TX machines, but with a different direction as far as users went. Clark and grad student Charles Molnar designed the next important computer that came out of Lincoln Labs. The LINC was developed to be used in laboratory situations such as operating theater, chemistry labs, and more. They chose a 12-bit word and 2,048 words of core memory, which was actually partitioned in a way. The first 1K words were usable for program execution, while the remaining could only be used for data. There were also many potential inputs for all manner of peripherals, which they knew would be necessary for use in labs. This meant the machine, to be used in a lab setting, had to consider a few things. 1, it had to be small enough to allow for integration into the lab setting. 2, it had to have multiple input and output capabilities for multiple kinds of data to be acquired and processed. 3, it had to be easy for non-computer professionals to train and use. And of course, none of those were minor considerations. This meant that the system had self-imposed limitations. That meant it couldn't fall within the time-sharing idea, which had been the dominant way to get computers into the hands of more people. It had to be small enough for a single user to use it in situ. In 1963, there was a summer workshop where a dozen or so users were invited to build the machines that would be used in their labs. These were not trained computer people, but people working in biology, chemistry, even doctors. This gave them intimate knowledge of the machine and also meant that the design of the machine, at least as far as building it went, had to be at least somewhat simplified. To this end, they employed DEC modules to build the logic unit out of, which simplified the process greatly. The machine is certainly an early mini-computer, and there are those who say that it's a first personal computer. I'm not one of them, by the way. It is one of the first to make its way into the laboratory, and it took the concept of the TX tape system and developed it into LINC tape. LINC tape was hugely influential on DEC, where they turned it into DEC tape. Something often overlooked in the design of the LINC was that it was a public domain design, and the plans were shared. DEC used the technology to make a few LINCs they sold, and Spear Inc. also made some commercially. Still, only about 50 or so were sold. The LINC technology was influential on other designs, including the PDP-4 and the PDP-5, and when the PDP-8 was released, and they started changing the world with it, it was combined with the LINC design to develop the LINC-8 for use in labs, which later evolved into the PDP-12. The TX machines engineering personnel headed out and started a company, Digital Equipment Corporation. Ken Olsen founded the company, bringing in many inventors and investors, including his brother Stan, to found the company that would commercialize ideas used in the TX machines. Ben Gurley came along, and DEC started by making memory test machines and modules. They truly came to the world's attention with the release of the Programmable Data Processor, or PDP-1. It was a board member, General Dorio, who insisted they don't call it a computer, largely because computers would require special approvals from universities and government, while data processors wouldn't get as much scrutiny. The PDP-1 had an 18-bit word and a 4K core memory standard. Each word was divided into 3 6-bit characters. It's a unique way of making for a more expandable memory, theoretically. The machine had all the hallmarks that would make DEC a leader. The system was comprised of standardized module types, with simplified Selectric-style typewriter, but it was the Type 30 CRT display that really turned heads. It had a built-in tape reader as well, right there on the front of the machine, making entering programs much easier. While it was not necessarily designed to compete with IBM's machines, it was designed to dig out its own niche, particularly within settings such as universities and even process control. though that was a consideration that would become more important as the PDPs progressed. The machine was really responsible, though, for creating hacker culture at MIT, which led to an incredible amount of impressive stuff from those who got their hands on the machine for the first time. The fact that the PDP had an incredible Type 30 CRT display made things possible from programs to be designed by users, including Steve Russell. Russell famously led the work on Space War, an incredibly important early computer game. The capabilities also inspired Peter Sampson to develop computer music programs. And folks like Marvin Minsky created programs like the Minskytron. It had the power of the TX machines, actually more so, the operability of the LINC, though at a larger size and higher price tag, but also the accessibility of all these machines. I'll be doing special episodes on Space War and early video games, but that's way down the line. The PDP-1 was a machine that got DEC on the road to where they would become one of the most important companies in computer history. We'll have several episodes dealing with DEC, including one on digital equipment from 1960 to 1965, and then the PDP-8 and Friends episode. The next episode will go back a tiny bit and look at the rise of the bunch of dwarves, those that competed with IBM in the 1960s, notably Burroughs, Univac, CDC, Honeywell, RCA, and General Electric. After that, we'll do some supercomputers in the early 1960s, followed by the one you've all been waiting for, the IBM 360. Thanks for listening to Computer History with Chris Garcia. I'll see you next time.